Hence, in our previous sessions, we have seen all about moving fluids, the equation of continuity, Bernoulli's principle, and also the thrust force. Over there, we had assumed that the air resistance, the fluid resistance, etc. are absent. But today, we will see the importance of the viscous force or the drag force, whatever you may call, and we're going to see how important viscosity is, and in certain situations how to avoid this drag force. There are certain liquids which are very viscous, like the lava out here is very viscous in nature. It flows but very slowly because of the immense drag force. On the other hand, if it was water, it would have flown very easily. So we're going to see all about it with me, Shreyas, your master teacher for physics at Vedantu going live. Welcome aboard. I hope everyone are doing fine and they're all fit, healthy, rocking, smiling, and also eagerly excited, and they are all waiting for this session. Welcome aboard. Hello Aishwarya, Fida, Sanspriya, Ranjit, and then Ankit, Tanmay, Uncharted, then alright, hello Aarti, hello Rishi, hello Sneha, hello Jumna, hello Saurav, welcome aboard, hello Papi, hello Bhakti. I'm very good Papi, how are you? Alright, Kirito has his own Japanese wishing style as usual. Hello Ranjite, welcome aboard guys. I hope you had an amazing time during this weekend. What lovely sessions you had, and I hope you also enjoyed the session on Saturday. So welcome aboard, and those of you who are new to this session, this is Shreyas here, and I have been teaching for almost a decade. I used to teach in corporate for first 3 years, then I left my corporate job and then I entered into JEE coaching. So during my JEE coaching, I have been training students, and many of my students have actually qualified the JEE entrance examination. A lot of them are now in IITs, BITS, NITs, you name it. Some of them have even scored 2-digit All India ranks. Some of them have scored, a lot of them have scored actually 3-digit All India ranks, and a lot of them are even abroad and many other great institutes inside India and even outside of India. So I hope that one day you are going to make me proud, and I can say proudly all about you. Alright, welcome aboard. I'm very good guys. So yes, the YouTube had crashed some time back, but glad that it is back, and yes, we are here now. Alright, so having said that, let me also tell you, do not forget to hit the subscribe button in case you are a new person out here. So the way you become a member of our Enthuse family is by hitting that subscribe button. So go ahead, hit that subscribe button, and if you have already subscribed, you know what to do. The usual, guys, smash the like button, because unless and until you smash, I'm not going to get that energy and you would not have paid the fees for this channel. So go ahead, smash that like button out there. Alright, so let's begin. Hello 79s, welcome aboard. Alright, hello Uncharted, welcome. Now let me also tell you this week's schedule. So we are dealing with mechanical properties of solids, liquids, etc. Guys, what did I promise you? Be it 11th standard student, be it 12th standard student, I'm going to cover all the topics before your board examinations, before your JEE Mains examination, to first attempt. I'm going to do every topic, and not that I'm going to do it really quick, alright, and not very slow, because I know the time is limited. So we're going to do all the topics. We're not going to leave any topic. So we are going to do viscosity, drag force today. Tomorrow we're going to start with surface tension. A lot of people just cover surface tension in one section or one session. That's not possible. So I'm going to divide it into two. On Wednesday we are going to talk about bubbles and capillary effect alone. And on Thursday, please keep in mind the lecture timing is not at 7 p.m. It's at 2 p.m. Be careful. The lecture on Thursday is at 2 o'clock in the afternoon, and that is elasticity, solids, stress, strain, energy. A lot of interesting things in that lecture again. Alright, so keep that in mind guys. And the Menti quiz this Thursday is going to be on fluids, viscosity and surface tension. All these fluid chapters combined, and because you asked that sir we want more than 12 questions, I am planning 15 to 20 questions at least. Alright, so 15 questions for sure, but let's see if I can make it till 18 or something. And that's why I had to start the quiz at 7:30 a.m. So that's why I'm going to start it at 7:30 a.m. in the morning. I hope you guys are going to show the Josh just like you show the Josh even at midnight. What say guys? Are you going to show the Josh? Friday, Saturday, yes. Why is it blank? I'll tell you. So I hope you're going to show that same Josh just like you have shown last Thursday at 8 o'clock, 7:30 a.m. It's going to be a big Menti quiz because there are going to be so many chapters: fluids, viscosity and surface tension, all of them together. Yes. Yeah, maybe uncharted, definitely, why not? We'll plan something midnight. Now, why were the sessions on Friday, Saturday blank? Any guesses guys? Any guesses why the sessions on Friday and Saturday blank? No, there is nothing special coming up over here, but it's actually blank. Any guesses? Alright, so you'll come to know why it's blank, but I'll be meeting you in a very different way. No, it's not surprise session. No, there are no sessions on that day. So the thing is, I'll tell you, no, I'm busy, yes, but in what way I'm busy? Uncharted. Leave, yes, vacation, but for what? But for what? Alright. No, magnetism Richu will be starting next week. Next week we're going to start. Yeah, but I'll be still catching up with you, hopefully from wherever I am. Alright, so guys, I'll be on leave on Friday, Saturday and Sunday because it's my wedding anniversary. Alright, so that's why I'm not going to be here. So, but I will somehow try and catch up with you probably on Instagram. If you're okay with me coming on Instagram, then I'll come up on Instagram live and hopefully I can meet you guys with my wife as well. Alright, so let's see how it goes. Alrighty, so let's begin today's session then. Alright, let's begin today's session. Yes, thank you Sneha, thank you and everyone, thank you Maya, thank you everyone, thank you Bhakti, thank you Ankita, Aishwarya, Saurav, yes Saurav, yes. Alright, so let's begin today's session guys, and like I was saying that we are going to first talk about the viscous force, and so many laws are there, so pay attention, make notes. Do not forget to write down all the formulas and the important tips, tricks and the hidden things inside this session. Alright, so keep making notes. Thank you Shreya, thank you Princey, thank you everyone. Alright, so remember I had shown you this diagram during Bernoulli's principle, and I told you that the lift produced in an aeroplane is because of the difference in the velocities of the wind flowing over the wing and below the wing, and that is because of Bernoulli's principle. So the weight of the aeroplane has been balanced by the lift, but the wind is sucked in through the engines and it is thrown behind, because of which there is a thrust force. Remember, we have also spoken about the thrust force in the fluid dynamics session. Rho A V square. So rho is the density, A is the area, V is the speed with which it is being thrown. That's the thrust force which is being produced. So you might be like, oh, the aeroplane should accelerate. Yes, it will accelerate provided this thrust force is more than the drag force, or it is not balanced by the drag force. You will see after some time the aeroplane moves with constant speed. So there must be some force cancelling out the thrust force. And that is nothing but the drag or the air resistance force, or I can sometimes also call it as the viscous force. All these things are the same thing. So what is viscous force? Viscous force is nothing but the resistance to the change of motion, the different layers of fluid when they move with respect to each other. The resistance to the motion of the layers of the fluid in liquids or gases is called as air resistance or viscous force or drag force. So it's basically fluid friction. Just like you had solid friction and you represented it, or you use the symbol mu for figuring out whether the friction is more or less. Similarly, you are going to see a similar symbol out here which will tell me whether the fluid is more viscous or whether it is less viscous. So viscosity or drag force is nothing but friction in fluids. That's all. And what happens? Well, the viscous force, does it have limit? No, the behavior is completely different. The laws are only completely different. That's why there is a completely different chapter. Alright, so it behaves very, very differently than the normal frictional force. Also, it's not dependent on the normal and all that, because here the fluid resistance or the viscous force comes because layers of fluid flow with respect to each other. So understand, if there is one layer of liquid moving and another layer of liquid moving and they are trying to move relative to each other, then you will see that there will be drag force or viscous force. Now, sometimes you do not want this viscous force. Like obviously an aeroplane would like to minimize its drag. So you need to design the shape of an aeroplane so that this drag is minimum. If this drag is minimum, then what will happen? The thrust required will also be less. And if thrust is less, then what will happen, guys? Think about it, less fuel. And if less fuel, then more profits, more money. Everybody is happy and they can then go very happily shopping for Christmas, Diwali, whatever. Okay, so that's the thing. Now another place where you wouldn't want viscous force is in a train. So when a train moves ahead, the air is going to flow over it. Now what happens is the shape of the train at the front has to be aerodynamically designed so that it encounters less air resistance. That's why you will see bullet trains are shaped in a very peculiar manner so that it pierces through the air and the drag that it encounters is as less as possible. Also, you will notice one more interesting thing, that these days in between the trains, that gap which is there between the bogies, that gap has been covered by putting some kind of a rubber sheet. Alright, so it is covered. Why is it covered? Because if it is not covered, then the air will enter inside these gaps and it will get trapped, and the moment it gets trapped over here, it produces more air resistance. So you do not want the air to be trapped between the compartments, because once it gets trapped, that's it. It's going to cause more air resistance and that's it. It's going to cause a lot of fuel. So that's the reason why, you know, the compartments are joined to each other. In fact, if you have seen the Vande Bharat Express and all the bullet trains abroad, so all these trains have very, very streamlined design and the compartments are all joined. All right. I hope this is very, very clear. Alrighty. Now one more thing about viscous force. Remember, this viscous force, they are non-conservative in nature. Alright, so this is friction. I just told you, friction in fluids. Then another thing, the energy is lost in heat, sound, etc. So there is some heat produced, some sound produced, etc. So all this energy is lost when you flow or when this force is being applied. And yeah, that's about it. And this happens because of relative motion of fluid layers. This happens because of relative motion of the fluid layers. So all these are important pointers. I hope you have noted it down. Some of them I had already mentioned. Okay, so very, very important. You can also take a screenshot if you would like. Okay, so now let us see what is the value of this fluid frictional force. So for finding that out, I'll define a term called as the velocity gradient. Now, if you have seen how the liquid flows or how the river water flows, it's very peculiar actually. The water which is close to the seabed or the river bed flows very slowly. Why does the water below near the seabed or the river bed flow very slowly? Because that water encounters lot of resistance from the pebbles, the stones, the irregular surfaces, the plants, etc. So because of which that water has to, overcome all these obstacles. It gets trapped over there. There is a lot of resistance at the bottommost layer. So that's the reason why this layer is the slowest moving layer. Now the next layer moves with respect to this layer. Now the fluid resistance, understand, fluid to fluid resistance is much smaller than fluid to solid resistance. Why? Because when the fluid tries to move over the solid surface like the bed of the river, then it has to overcome all these stones, pebbles, plants, etc. But this fluid, when it tries to slide over this layer of liquid, it's going to be very smooth because liquids can take any shape and size. So that's the reason why this layer will move very smoothly over this layer. The layer above that will move even more smoothly. It will move faster than this layer, and this layer will move even faster, and this layer will be the fastest. So the topmost layer you will see is always the fastest layer inside a river. And why are these liquid particles moving? Because maybe there is a waterfall behind, maybe there is a source from where the river water is being originated, and it is being continuously being pumped out inside this river. So it has to move from a higher point to the lower point. So you will see there is continuous water coming over here, and the layers prefer to move faster here because it's very easy to slide over here. I hope it is clear. I hope this is clear. All right. I hope this is fine. And usually what happens, the lowermost layer moves so slowly, it's almost having negligible velocity. So generally for solving questions, you can take the lowermost velocity almost as 0, guys. So it's fair enough to assume the lowermost velocity as 0 because it is hardly moving. It takes a lot of time to work its way around those pebbles, those plants, and those uneven surfaces. Very, very important. All right. Which type of fluid will have more viscous force? Excellent question. Things like honey or the sauce. Have you ever tried to open a bottle of sauce and try to pour that sauce on your bread or on the, I don't know, French fries or burger or pizza or whatever? See how viscous it is, isn't it? It's very viscous, guys. So that's a very good example. Honey as well. No. Is density related to viscosity? No. What is viscosity going to be dependent on? Viscosity will depend on the molecular bonds, attraction, etc., even the temperature. And I hope you know that temperature will affect viscosity, and you would have realized this if you have placed a bottle of sauce in the freezer, and when the bottle of sauce is outside, and when you try to pour that sauce in a warmer, relatively warmer temperature, you know where it is more, where it is less. And in fact, there is going to be a question on that very soon, so stay tuned, guys. Alright, so now we are going to define something called as the velocity gradient. So whenever velocity changes with respect to distance, that is basically called as velocity gradient. So it is nothing but rate of change of velocity with respect to the layers of fluid. Not with respect to time, because rate of change of velocity with respect to time is acceleration, guys. This is not acceleration, this is a rate of change of velocity with respect to the layers. So now how do we exactly write it? So just imagine that there is this layer which has certain velocity, example v. The layer over it, all right, it has a velocity v plus dv. It has a layer above it which is moving with slightly more speed, because the difference between these two layers, the distance is hardly dy. So the distance between them is hardly dy. Dy is the small distance. These layers are infinitely small, as thinner than paper, even much thinner than paper. Just imagine that. And that's why I'm saying the difference in the velocities is just dv. Now the velocity gradient, okay, so velocity gradient is given by change in the velocity, right, divided by the distance between the layers, which is nothing but dy. So this is nothing but velocity gradient, dv by dy, rate of change of velocity with respect to those layers. So that is velocity gradient. And if you would like to see what is the unit of it, well, velocity has the unit of meters per second, and distance has the unit of meter. Meter cancels, and it will become 1 by second. But please understand, this is not written as hertz, because hertz is an unit only for frequency, not for velocity gradient. Please understand, just like work is Newton into meter, but you do not use joules for torque, because even torque is Newton into meter. For torque there is a separate unit, that's Newton meter. For work, the unit is joule. You do not use joules for torque. Same way, do not use hertz for velocity gradient. Very, very important. So let's begin next part of this. So what is Newton's law of viscosity tell us? Now that we have defined what is velocity gradient, it says whenever you move one layer over the other, and if you know the velocity gradient, then you can figure out what is the drag force between the layers. So if F is the drag force between the layers of fluid which are sliding with respect to each other, if A is the area of that layer, then according to Newton, when he performed a lot of experiments, lot of 100 years back, he found out that the drag force was proportional. The drag force was proportional to the area of layers in contact, and it was also proportional to the velocity gradient. Now you can combine both these things into one single statement. That drag force will come out to be a constant into area into dV by dy. dV by dy is the velocity gradient. I just told you the constant of proportionality is called as eta, which is called as coefficient of viscosity. Alright, so it is just called as coefficient of viscosity. If somebody has large value of coefficient of viscosity, it is more viscous. And if it is equal to 0, then it becomes an ideal fluid, because it will have no viscosity whatsoever. So that is what we assumed in the previous chapter of hydrodynamics. But more the value of eta, more is the viscosity. It's similar to coefficient of friction, but just understand one thing, this will be given to you, or you will have to find it out by other information which will be present inside the problem. So don't worry, you don't have to by heart these values. For air, for water, for glycerine, for oil, you don't have to worry about it. I hope this is clear. Alright, so more the area obviously makes sense. More the area, more the viscous force, more the touch points which will be there, and more the velocity gradient. Faster is the rate at which the velocity is changing, then also the viscous force will be more. So that's how it is, and that's what you should remember. Now this eta, alright, this eta, you can figure out what the unit is. Just one second. Since F was eta A dV by dy, this force was in Newton. I want to know what is the unit of eta. Area is nothing but meter square. dV by dy, we just saw it was 1 by second, because meter cancelled out. So the unit of eta will be nothing but Newton per meter square into second. So Newton second per meter square. But this will be obviously the SI unit. In CGS, it will be dyne, and then you will have centimeter square and second. This is CGS unit. And please remember, the CGS unit has a special name. It is called as 1 poise. So the CGS unit has a special name called as 1 poise. And if you do the conversion, this is what you will get. 1 SI unit is basically 10 poise. So 10 poise is 1 SI unit. This is something you should know. Lot of times NEET, JEE Mains, KVPY, BITSAT, CETs have been asking questions on these conversions, and a lot of people don't remember who was how many times. So please remember this value. Please remember this value. Okay? Very good, guys. So keep on learning, keep up the spirits, and do not forget to hit that like button. If you have not yet liked that button, please do it, and if you have not yet subscribed, go hit that subscribe button, guys. Now let's go ahead to some problems. So here comes the question in front of your screen. In which of the following ways does viscosity change while you increase the temperature? So if you increase the temperature, what happens to the viscosity? Options are: in the gas it increases, in liquids it increases, then it decreases, increases, increases. So what do you think happens to viscosity? Think about it. Try to recollect some past memories and see whether you can now figure out what the correct answer should be. Yalmala, can you do one thing? Can you post a comment after the session? I will reply to you peacefully, not maybe in the live session, or maybe you can ping me on my Instagram. I'll definitely help you out, or post on YouTube itself. All right, a lot of you are saying C, some of you are saying D, and some of you also said B. All right, let's see what the correct answer should be. The correct answer is C, guys. For gases it increases, but for liquids it decreases. Liquids, it's very obvious. You take a bottle of sauce, put it outside and make it warm, that's it. The sauce will flow very easily. You would have seen that. It flows very easily. The viscosity decreases. Reason, the bonds become weaker when you increase the temperature. So that's the reason why viscosity will decrease for liquids. Now this same question came in previous years in BITS, in CET, KVPY, everywhere this has been asked, and this is such a popular question. You never know how it might come. Now please understand, for gases it increases. You'll be like, sir, why? Reason is, for gases, understand, the viscosity is not because of the bonds. Because first of all, gas molecules do not interact so much with each other. The viscosity came in the first place because the molecules collided with each other. So imagine I am moving my hand in air. The viscosity, the drag force I am experiencing is not because the air molecule is forming a bond with my hand, but it is because the molecules are colliding with my hand. And that's why when you increase the temperature, the molecular speeds increase, and that's why there will be more collisions and there will be more resistance. So that's why for gases it increases, whereas for liquids it decreases. So keep this in mind. Next question coming up on your screen. I hope this is very clear. Yes, I know it's a nice one. Get ready, guys. Next question coming up on the screen. Yes, thank you, Saurav, for sharing the ID for the needy. Very good, very good. So in the flow of a viscous liquid over a flat horizontal surface, the velocity is 0.4 centimeters per second at 2 millimeter distance above. The flat surface moves in the opposite direction with this speed. What is the velocity gradient? So think, guys, there is a horizontal surface, okay, and over that there is some liquid. What is the layer of the liquid? 2 millimeters, and the top surface is moving with the speed of 0.4 centimeters per second. The flat surface below moves in the opposite direction with 0.2 centimeters per second. What is the velocity gradient? Come on, you can do this, guys. Come on, come on. Hello Navneet, welcome, join in. Long time. Come on, come on, come on, guys. Survinder, what happened? What extra classes? Survinder, don't spam so much. Just ask once, I'll answer. Okay, a lot of you are saying A, Uncharted is saying C. Yalmala, I think Saurav just gave it. Shreyas _ Vedantu. It's also there in the description box below. Shreyas _ Vedantu. That's my Instagram handle. Are you Survinder? That's an recorded class. That's a simulated class. That's why. Okay. Alright, a lot of you are saying C now. Alrighty, let's see, guys. Come on, what's the correct answer? In a minute. Bhakti, Science Priya, VK channel, Uncharted, Shreya, Shabana, VK, Aarti. Everyone is saying C. Okay, Survinder, but don't put the same message twice. I know you're not spamming. No problem, no problem. Yeah, the thing is that is simulated, or that is the recorded session on the Vedantu app. Alright, don't worry. Okay, so let's get going, guys. Alright, so the correct answer is 3 per second, and let's see why the answer is 3 per second. So the logic behind it is, the liquid's top surface, alright, is moving at a speed of 0.4 centimeters per second. The bottom surface is moving in the opposite direction with a speed of 0.2 centimeters per second. And the thickness is how much? It's 2 millimeters. Now understand what was velocity gradient. Velocity gradient was change in velocity upon the distance. Now the distance is very evident. It is 2 millimeters. So I can also put it as 0.2 centimeters. That's better. Alright, 2 millimeters is 0.2 centimeters. But what is the change in velocity? It is not 0.4 nor is it 0.2, but in fact it is the addition of both of them. Why? Think about it. If you place this bottommost point, alright, the bottommost layer at rest, with respect to that, what speed will the topmost layer move? So if you sit on this and look at the topmost layer, obviously it will appear to move with a speed of 0.4 plus 0.2, guys. So hence the answer on the top, the numerator, should be nothing but 0.6, and that's why centimeters per second, and that's why the answer is 3 per second. I hope this is clear. Understood, guys? Yeah, a lot of you I know subtracted. You thought it was opposite, so maybe you have to subtract. But relative motion, guys, that's why I taught you relative motion at the beginning. I could have done all these things in a very random manner, but trust me, guys, when I have planned for JEE Enthuse, for this channel, I have sat down for days, for hours to plan the entire lecture schedule. Trust me when I say that by January or maximum February first week, I'll be preparing you for everything, and soon I am planning many more extra things which will be told to you. Don't worry about it. Alrighty. So let's get going to the next question, and here it comes. Let's see how many of you get this. A block of certain side A, density rho, slides over a fixed incline with a constant velocity v. There is a thin film of a viscous fluid of thickness T. Remember, the density is not of this layer, but that density is of the cube, not of the layer. Please understand. There's a film of fluid of thickness T between the plate and the block. Then the coefficient of viscosity of the thin film will be. Assume that the layer of liquid stick to their corresponding surfaces. So assume the lowermost layer sticks to the inclined plane and the topmost layer sticks to the cube. Assume that, and then you will be able to do it very easily. Yes, Shabana, I will be doing strategy sessions also. I hope you have seen my previous timetable management, JEE important news. In that also I have given some very important strategies for question paper. Please watch that, and even Shimon sir and other people also have done some strategy sessions. I'll be doing some very important sessions as well. But I'm also planning to take up some crazy topics in physics, guys, like 4 dimension, or what is this time, what is this space time, what is this quantum physics and stuff like that. These are exciting stuff which not many people talk about, because not many people have explored all this. So I want my knowledge to be shared with you. So I'm going to take up these sessions as well. All right, let's have a look. Somebody saying C, somebody saying come on. Figure it out, guys. It's not that difficult. Uncharted says D. I don't know, Saurabh. I'm going to see in a bit. What state has the most viscosity for one substance? So Krito, out of gases and liquids, liquids have more viscosity. So if you compare water and air, water will have more viscosity, but you cannot compare ice because ice is a solid. So for ice you have friction. Alright, Jan C said C, Mohammed says C, A, Princey says B, Fida says A. Alright, let's have a look at the correct answer. The correct answer is option A. Let's see why option A. Now, the logic behind this is the velocity is constant. If velocity is constant, that means, guys, very quickly you should understand that the acceleration is 0. And if acceleration is 0, then all the forces must cancel out each other, be it anywhere. So if there is an mg sine theta force down the incline, and if there is mg cos theta force perpendicular to the incline, this mg cos theta will be balanced by normal. But since there is a force here, there must be some balancing force so that the acceleration is 0, and that must be none other than the drag force itself. So very clearly from this I get that the drag force should be equal to mg sine theta. Now if you concentrate, alright, if you concentrate on that layer, you will realize the layer which is in contact with the block will be moving with the speed of the block. The layer below it will be moving with less speed, and the layer below it with more less speed, and finally the layer which is in contact with the inclined plane will be at rest. And what is this thickness? This thickness is given to be T. So from this you know what the velocity gradient is, and that's why you can write the drag force down very easily. So what was the value of drag force? Eta A dV by dy is equal to m. Oh, wait a minute, I can get rid of this m. How? By writing it as density multiplied by volume. So density into volume of the cube into g into sine of theta. Now eta is as it is. Area of contact will be the sides area, any one side. It's a cube, right? It's having a side a, so this will be small a square. dv by dy, the change in the velocity is just v. From 0 it has gone to v, and over a thickness or layer height of t, so it will be v by t is equal to density into volume. What is volume? A cube into g sine of theta. Now what is the question? The question is, what is the viscosity? So viscosity will be, first of all, cancel this a square with this a cube. One of the a will be remaining, and what will you get? Rho a g sine theta, and that t will go on the top and that v will stay below. So that's what the answer is. Rho a g, t is also there, and sine theta is also there, and v is there below. I hope you got it, guys. I hope you got it. I hope this is clear. Everyone understood? Everyone understood this question? How to solve this? Very, very important question. This kind of questions have come in JEE in different ways. They have also come in KVPY. So very, very important. Alrighty, alrighty. Now let's talk about something very interesting, guys. Now imagine if I drop a stone from a very tall height, like say 1 or 2 kilometers. By the time it hits your head, the speed will be few hundred meters per second. Correct? So a stone falling from a very large height will hit your head with a large speed. Now, if I ask you, what if I drop water from a very large height? Will it hit you very hard? Then you'll be like, come on, it's water, right? Obviously, water is not going to hurt me so much. But believe me, if water is dropped from a very large height of say few hundred meters or even a kilometer, then understand it's going to be very bad. It's going to damage your head. Yes, it's not going to be very nice. Trust me about it. In fact, if you have visited the dentist and if you have got your teeth cleaned, or maybe, I don't know, teeth removed or something like that, or some kind of an operation on your teeth, then they use some kind of a pokey material and they, put it on the teeth, and it feels like somebody's drilling something using some steel-like material. Believe me, it is not steel. Yes, it is not steel, guys. It is in fact water. What? Are you kidding me? Sir is lying for sure. No, guys. When they use something to clean the teeth, it is not steel. It is a jet of water coming at such a high speed that it feels like steel. Yeah, it feels like steel. But actually speaking, it is water. How many of you have experienced this? Please put it up in the chat box so that you guys can also exchange your ideas. Amazing. Yeah, Uncharted thought it was a drill. My God, look at that. Yes, the speed is so high. So guys, imagine water comes and falls on your head with such high speed. What will happen to you? Your head will burst. But luckily, the nature is so clever. The things around us have been planned in such a beautiful manner that these things like this do not happen. And why it doesn't happen, you will see it in a bit. Now, before that, let me also tell you about the crash course for all the 12th standard and 11th standard students. Guys, this crash course is phenomenal. It's a very huge success. A lot of students have joined in, and believe me, this is going to be there with you till your final attempt of JEE Mains. And this crash course begins every Monday, and you have 120 sessions, and you have 10 full syllabus and 10 part test series, and you also have two-way learning platform where you can also interact with the second teacher, because we follow two-teacher model where there is a master teacher and there is a class teacher inside the class who is continuously handling all your doubts. and you are often divided into small sections so that each class teacher can cater to a small group of students. And even after the class, if some doubts come up, then you also have the doubt facility within the Vedantu app right from morning till the night, and also some special sessions for tips and tricks by all the renowned faculties in the country. So some of the teachers out here are very well known, and I personally know them. I can vouch for them. Guys, they are very good. So you should go ahead and register. Do not have second thoughts that I can manage, or my offline coaching is going to do it. Trust me, your offline coaching is not going to do so much as what you are going to get over here with so many sessions. That too, you don't have to go anywhere, and all the test reports etc. will be shared with you. So the course price for the crash course was 10,000, but now it has come down to 7,000 rupees, and the coupon code by which you can get that 30% off is SHCC. So the link for joining the crash course is in the description box below. So go ahead, smash that link, open it up, see everything about it, read all the FAQs, and once you're convinced, only then join it. And do not forget to use the coupon code, because without that coupon code, you're not going to get that 30% off. And if you feel that okay, some relative or some cousin is going to be benefited from this course, then please go ahead, share this link as well as the coupon code with your friend or your relative. All right, so let's get going with the next important concept, and that is the drag force experienced by a spherical body. Now in JEE we only have spherical bodies, but if you take fluid mechanics or aeronautical engineering or naval architecture or maybe automobile engineering, when you enter into IIT or NITs and any other prestigious institutes, then you will be seeing all different shapes, all the drag forces experienced by any random shape, and the calculations are not so easy. You need matrices, differential equations, God knows what. You need so many crazy things. But luckily for us, at JEE level, we have only spherical bodies and only the direct formula for that. So a spherical body moving through a fluid, look at this, it's so relaxing, soothing to the mind just to observe this fluid move over the spherical surface. So the drag force experienced by spherical body is given by something called as the Stokes law. So what did Stokes say? He said if fluid is moving over a spherical body whose radius is r, and this fluid particles are moving with a speed v relative to the ball or that sphere, either the fluid is at rest and the ball is moving, or the ball is at rest and the fluid is moving. There is no difference whatsoever, understand. So it's relative velocity, please keep that in mind. Then understand the drag force experienced. Alright, so because the fluid is going to push it that way, other way to think about it is the fluid is at rest and the ball is coming this way. So if the ball is coming this way, the drag force will be that way. So the drag force will be here, and this drag force, Stokes law, only for spherical bodies, and the flow is laminar. That is, it's not turbulent, it's not unpredictable. So the flow is very smooth, it's going over the sphere in the form of layers, only then this is valid. And the drag force is given by 6 pi eta rv. So very, very important formula. 6 pi is the constant, eta is the viscosity of the fluid which will be given to you, or you can figure it out by other data. R is the radius of the sphere, v is the speed of the fluid relative to the sphere. I hope this is clear. Yes, Daniel, I have completed laws of motion. Please go ahead in the video part or the playlist part. You will see nice playlist arranged. Okay, so beautiful playlists have been made chapter wise for physics, chemistry, maths. Please go ahead and check it out after the session is over. All right, excellent guys, very good. Yes, Shabana, gulab jamun, yaad aa gaya. Thank you, amateur Buddhist, so much. All right, let's do a question on this. Let's see how many of you can get this question right, guys. Come on. The power delivered in moving a spherical body in a viscous fluid is proportional to which power of the velocity? Options are 2, option B 1, option C says half, option D says 3. Come on. Why it only works on a spherical body? So the thing is, Stokes derived it. The 6 pi eta RV comes after integration, differential equations and so many other considerations. So after that derivations, he found for spherical body it comes out to be this. For a conical shape it will come out to be slightly different. The constants, the formula will change. Alright. No, 17s, drag and friction are slightly different. Friction is the word used for, solids. Drag or viscosity is used for liquids or gases. Alright, let's have a look. The correct answer, by the way, for this question is option A. Now, if you're wondering why is it option A, let me tell you. So the power is nothing but force into velocity. So if you're going to push an object, you need to apply some force, and that force should at least balance the drag force. So what is the drag force? 6 pi eta RV. That's the drag force. And that velocity will again come there. So you'll have 6 pi eta RV square. So clearly power is proportional to the square of velocity. So if you're spending 100 watts for a speed of 20 kilometers per hour, you will have to spend 400 watts for a speed of 40 kilometers per hour. So if you double the speed from 20 to 40, the power that you are wasting against that frictional or air resistance force is going to become 4 times. That's how crazy it is. Alright, excellent guys. Amazing go. Let's get going to the next concept which is going to come up on your screen. Get ready guys. Alrighty. So the next concept is called as terminal velocity, which explains why water does not rip your head apart. You should be thankful that because of viscous force, sometimes yes, viscous force is bad, but now at least you should be thankful for the viscous force, because only because of that the water does not rip your head apart. Because what happens is, as water begins to accelerate towards the earth from a cloud, when it forms drops of water and falls in the form of rain, what happens is the drag of the air slows it down. It's like, hey, come on, slow down. You need to take care of the humans below on the earth. You cannot speed up so much. So it slows it down, and by the time it falls on the surface of the earth, a lot of energy is lost and it falls down with a very small speed. And that constant speed with which it falls down, alright, it no longer accelerates. It falls down with constant speed. That speed is called as the terminal velocity. So terminal velocity is like the brake on those raindrops so that it does not accelerate, and it falls with one constant velocity called as the terminal velocity. Excellent. Does everybody have a terminal velocity? Yes. And this experiment is usually performed in your laboratory, but corona times, no labs, you cannot see this. And if you enter engineering colleges, you will be probably doing this experiment in your first year of engineering. So what happens is, there is a big tower, it's full of oil, viscous oil, and you have to drop a stone or a body, a spherical body, and it falls down. And then it comes down with one constant speed. And you can measure the terminal speed by marking 2 points on that beaker or that big tube, and see how much time it takes to go from one point to the other. And you see that that's how terminal speed is calculated. And in fact, using reverse engineering, you calculate the viscosity of the fluid. So we're going to see the formula for terminal velocity now, and in fact by calculating or observing terminal velocity, you can reverse engineer and figure out what is the viscosity. Alrighty, yes Aarti, that's oil drop experiment. Yes, correct. In fact, Millikan oil drop experiment is also based on a very similar concept, by the way. Alrighty. So let's get going and let's figure out what exactly happens in terminal velocity. Very important guys. So imagine, now this is something which nobody tells you, and it's not even there so nicely in most of the books, so pay attention. Imagine a drop just begins to fall down. So what did the drop do? It just began to fall down. So what happens at t is equal to 0? The velocity is 0 because it has just started. But what are the forces acting on that drop? One is obviously the weight. Second is the buoyant force by air or whatever fluid is being surrounded by. So weight is there, buoyant force is there, but drag force is not there. Like, sir, why? The viscosity should be there, right? Guys, do not forget, drag force is 6 pi eta r v. If v is 0, drag force is also 0. So if you are not moving relative to the fluid, drag force will not be there. So be careful about it. So there is no drag force now. Okay, good for us. So what will happen then? So what happens is, there will be an acceleration downwards. Alright, so there will be an acceleration initially. And what will be that acceleration? You can figure it out. So weight minus buoyant force is mass into acceleration. Therefore, acceleration will be weight minus buoyant force divided by mass, of course. Now there is a very interesting thing that is going to happen. Now, because it is accelerating, so the velocity will increase. So within no time, it will definitely gain some velocity, and this is at some time t is equal to t. Some time t is equal to t. What are the new forces? Well, weight is going to be there, buoyant force is going to be there, but there is one additional force which is going to come in. Who is that? Drag force. So velocity is down, so drag force is going to be up, and you are going to see a drag force acting up. So you're going to see that drag force acting up, guys. Yes. Now the crazy part about this is, this drag force, unlike buoyant or the weight, is not a constant force. Yes, this drag force, keep in mind, is proportional to velocity. If you increase, I will also increase. If you decrease, I will also decrease. So as the velocity increases, even the drag force increases. So what is going to happen? Let's check it out. So now the acceleration at any time will be, again, weight minus buoyant force minus drag force is equal to mass into acceleration. Rearrange and you will get weight minus buoyant force minus drag force divided by mass. Now look at these two things. This was acceleration at some time t. Alright, this was acceleration at some time t. What is happening? There is one extra term here. It's becoming less. So what is happening, guys? From here to here, check it out carefully. The acceleration is decreasing. The acceleration is decreasing. You can clearly see that. Slowly the acceleration is decreasing. But does it mean the velocity is also decreasing? No. Velocity is still increasing. Now this is something which people fail to understand. People say, sir, acceleration is decreasing. What the hell have you written? You have written velocity is increasing. Something is wrong. No, nothing is wrong. Guys, acceleration is decreasing means the rate at which velocity increases is decreasing. So velocity increases, but as time progresses, the velocity increases at much slower rate. It increases. First, if it was increasing by so much, next it increases only by so much, next it increases only by so much. Understand the concept. A lot of people never get this, and this has come in JEE, this has come in so many competitive exams, and people have written acceleration is decreasing, velocity is also decreasing. How is it possible you drop something and the velocity decreases? If velocity decreases, then it should stop, and once it stops, it should again go up. What nonsense. Obviously, it should not happen like that. Okay, so guys, velocity is increasing, but rate of change of velocity is decreasing. That's what is important. Very, very important. Yes, correct. Alrighty. A lot of you have put up those bulbs, so looks like it has enlightened all of you. Now, what will happen eventually? Eventually, what will happen, guys? The buoyant force, the drag force, and the weight will be perfectly balancing each other. This is after a long time, and that's why the acceleration will be 0. Remember, acceleration was reducing. Eventually these two will cancel out each other. Acceleration will be 0, and that's when you will see that this velocity is going to be a constant, and this is called as the terminal velocity. So this is called as the terminal velocity. I hope this is clear. I hope this is clear. All right, excelente. Keep writing it down, guys. Come on, come on, come on, do it. I hope you have written it down. Thank you, Buddhist. You guys are my true gems, guys. You guys are my true gems, because without you, I won't get the motivation. Trust me, I love teaching. Trust me, I love physics. And trust me, I want to tell you so many things, but there is so little time. And guys, I'm taking so many batches in the regular Vedantu batch classes as well, the long-term batch, the micro course, this course, that course, so many things I'm doing. And not just that, beyond that also I do so many other things in Vedantu. So that's why I have to, justify everyone. And whatever I do, I'll do it properly. All right. Okay. So let's get going to the next thing. And this graph is also very important. You can see this dude out here who is jumping from a very tall height. Look at the red graph. The red graph is velocity. The green graph is acceleration. You will see the acceleration gradually reduces, becomes 0, and the velocity increases, but rate is slowing down, and eventually it becomes constant, and that is nothing but terminal velocity. That also happens with parachutes. All right. So what is the formula for terminal velocity? The formula for terminal velocity is 2, 9. Which alphabet looks very similar to 9 and which you might think that you should cancel? Come on, think about it. It is G. So put G on the top. Alright. Often people get confused during the exam. They write 9 and G similarly and they feel that, oh, 9 and 9 cancel out. But actually they are very close, because G is almost 9.8, but they are not exactly the same. Okay, so that's how you're going to remember it. Yes, very good. Yes, very good, very good, very good. And then you have eta below, and you have r square on the top, and you have difference in the densities. Okay, so what is each term? I'll explain. Hold on a second. Eta everybody knows, it is viscosity. G everybody knows. R everybody knows is the radius. What is this rho and what is this sigma? Rho and sigma, it depends, guys, which one you take first. All right, some people can write it like this as well. That's okay. You can write it as sigma minus rho. It depends how you want to write it. Let's say you write it like this, then that sigma stands for the density of that solid sphere, or basically that spherical body. So whatever is that sphere, it could be a raindrop also. So that sphere's density is sigma. Rho is the density of the fluid around it, and this eta is also the viscosity of that same fluid which is around it. Very, very important things. So sphere's density is sigma, density rho is the density of air, etc., whatever is there around it. Eta is the viscosity coefficient of air. So keep this in mind. Very good. Now I'll tell you the beautiful part about this formula. What is the beautiful part about this formula? Observe. Guys, just imagine this. All right, I'll just write it over here. Imagine a case when sigma is more than rho. If sigma is more than rho, terminal velocity will be positive. And if sigma is less than rho, then terminal velocity will be negative. What does this mean? It means if the sphere's density is more than the density of the fluid around it, it will fall down with terminal velocity. But if the sphere's density is less than the density of the fluid around it, it will move up with terminal velocity. It will move up with terminal velocity. Example, this balloon. Helium balloon, if you leave it, what happens? It moves up with terminal velocity. So that's where you can use the formula. This kind of question has also come. Find the terminal velocity of helium. People got confused. Which formula should I use? Will that formula work or not work? It will work. Just that you will get a minus answer or a negative answer. It just tells you it is moving up. That's it. Correct. Correct. And if sigma equals to rho, you know what is going to happen. Guys, it will just float in that liquid. It is neither going to go up nor it's going to come down. That's obvious. Alright. So that's why I didn't discuss that. I hope this is clear, and I hope many of you have watched this movie as well. Please watch this movie. Very, very beautiful movie. I'll not tell you which one, but you watch it. You can guess. Alright. So here is the next question coming up on your screens. A metal ball of radius r and density d travels with a terminal velocity of v in a liquid of density d by 2. The terminal velocity of another ball of radius 2r and density 2d in the same liquid is how much? How much is the new terminal velocity for a different ball of different density? Come on, think about it. Yes. Chandan, I'm not sure. Maybe your internet connection might be slow, Chandan, or just check. There is a setting on this side which tells you can increase the clarity. You can make it from 360p to maybe 480 or 720p. Please change that, Chandan. All right, come on, guys. Yes, Princey likes balloons. Will it be or negative? Sort of which doubt? Amateur, no, it will be enough for NEET as well, but there will be some advanced sessions which I'll be conducting, and in my sessions I also conduct advanced level problems. So my session is a mix of mains plus advanced problems. All right. So let's get going and see what's the correct answer. The correct answer is A. Shreya said A. Many of you said C. I don't know why, what went wrong. So let's have a look what went wrong, guys. All righty. So what is happening is, if you look at the formula of terminal velocity, it was 2 by 9 g r square sigma minus rho divided by eta. This was our formula. Now let's do this. When the velocity, terminal velocity was v, all right, travels with a terminal velocity v for a metal ball of radius r. Now think about it, g, 2, 9, eta, all these are constants. All these are constants, so don't even worry about it. So just think of it this way. The old terminal velocity upon the new terminal velocity will be the ratio of the radius. Alright, ratio of the radius. This is radius. Then difference of the densities. Difference of the densities. So difference of density. That's all. That's going to be there. So initial radius was r, final radius is 2r. So r and 2r. Density wise, the ball's density was d and the liquid's density was d by 2. So d, solid sphere's density, minus liquid's density. Remember, that is what I had told you. This is the sphere's density, this is the fluid's density in which it is moving. Next time also it is moving in the same fluid, so put d by 2 here also. But the sphere which is there, sigma, the density will be different. How much is it? It is 2d. That's it. Now things are very clear. R cancels, 1 by 2 square is 1 by 4, guys. And d minus d by 2, half. Alright, the dd will get cancelled anyways. 2d minus d by 2 is 3d by 2. So obviously 2 also gets cancelled, and that d also has gone out. Alright, so 2 gets cancelled, so it will become 1 by 12. That is nothing but v by v1. So v1 will be 12v. That's the answer. I hope this is clear. I hope this is clear. Very, very interesting question, and these kind of questions can definitely comes in mains, advanced, bitsat, no matter where. Alrighty. Oh, very bad, Princey. I hope it becomes well very soon. Now, last part of viscosity, guys. Trust me, just because you have spent few minutes or just an hour or so with me, now your marks in viscosity chapter are guaranteed in the final examination, just because you have sat with me today. That's it. After this, you just solve problems. That's it. Guarantee you are going to get, if a question comes in JEE, NEET, BITSAT, KV, PY, boards, doesn't matter, those marks are guaranteed just because you have attended this class. Alright, and this is what is going to happen if you attend all the sessions. You are slowly going to get grab those marks. A lot of people ask me, sir, when do I actually start, or how are the marks in my examination determined? Is it those 3 hours? What do you guys think? Ranjit, those fluids which obey Newton's law of viscosity are called as Newtonian fluids. That's all. Some things which don't, they are very weird, they are non-Newtonian. So when do you think you actually start scoring marks in the examination? Do you think those 3 hours or whatever, 6 hours you spend in the examination hall, that decides what you are going to score? No. In fact, you have started writing your test from day 1 of your 11th standard. Day 1 of your 11th standard, when you started your coaching for JEE, and if you have not started in 11th, whenever you started your coaching, that's the day you started writing your final examination paper. So even now, you are writing the final examination paper, guys. You'll be like, sir, where is the paper? Guys, remember, whatever you are learning now will be used. And if you don't learn now, if you don't pay attention now, that will be going waste. So understand, you are right now writing the paper. In fact, you have started writing it a long time back. All right? Yes, a lot of patience, 2 years of patience, I would say. So we have seen different kinds of flow previously. Steady flow, which is predictable, or laminar flow. Layers of fluid move with respect to each other, like the water flowing through this pipe. Layers of fluid, cylindrical layers, are flowing over each other. And if you see the cross section of the tube, you will see the center part is moving with large speed. The layers around it are moving slowly. Turbulent flow, it's unpredictable, random flow. The streamlines get completely mixed up, jumbled up. So that is called as turbulent flow. Now, is there a way to figure out whether the flow is steady or turbulent? And the answer is yes. And let me tell you how. So imagine there is a liquid flowing through a tube. All right, there is a liquid flowing through a tube. All you need to know is what is the velocity, the diameter, the density, and the viscosity of the fluid. That's all. And Reynolds found out a very crazy magical number called as a Reynolds number, and that is rho v d by eta. If you find out this Reynolds number, it's a magical number, guys. He found out that if Reynolds number is typically less than 1000, then the flow is steady or laminar. And if Reynolds number is typically more than 2000, then the flow is turbulent. Now obviously you will be like, sir, what if it is 1500, 1200, etc.? What if it is between 1000 and 2000? Then the answer is can't say. Basically, it can be either steady or turbulent, or it can sometimes become turbulent, sometimes become steady. So it is kind of unpredictable. But for sure, if it is less than 1000, the flow is steady, and for sure above 2000 it is turbulent. That's what you should know. Yes, that Reynolds pen, no, that's a completely different thing, guys. Don't get confused. There are other kinds of Reynolds as well. All right, okay. So remember this magical number. Yes, rho vd by eta. I hope you have written this formula down. Now let's, oh, by the way, remember these values, guys. Less than 1000, steady. More than 2000, turbulent. Between them, unsteady. It can be sometimes steady, sometimes turbulent. You cannot be so sure. Alrighty, let's get going to a question. And this is the last question for today, and I'll be showing you all the stars of the previous session who have solved the homework and who have posted those answers in the comment section below. And I'll be also giving you 2 homework questions whose solutions will be again put up in the Telegram link below. Alright, so Determine whether the flow is laminar or turbulent if glycerine at such a temperature flows in a pipe of radius 12.5 centimeters. The average flow is 1.9 meter cube per second. Density is given, coefficient of viscosity is given, everything is given. Just find whether it is laminar or turbulent. What do we do? Start with the basics. Reynolds number, beautiful magical number. It is rho v d by eta. The problem is v is not given. Volume flow rate is given. This is how they can couple the question with fluid mechanics and viscosity. In fluid mechanics, we have seen volume flow rate is area into velocity. We have seen that. So this v can be written down as volume flow rate divided by area, and rest of the terms will be as it is. Isn't it? I hope this is clear. Now just write down these things in a slightly better form. D is nothing but r by 2. Diameter, oh sorry, what did I just say? This is Q, okay, and that is eta, and what else was there? Area was also there. Area was there and eta was there. Oh, diameter is nothing but twice of radius, correct? Diameter is nothing but twice of radius. And what is area? Area is nothing but pi r square, and eta will come over as it is. Now r's will get cancelled, so 1 r will get cancelled, and now it becomes a little bit simpler to solve. So let's just substitute the values. Rho, what is rho? It is 1250. Q is volume flow rate. What is the volume flow rate? It is 1.9 into 2 divided by pi as it is, or 3.14, multiplied by r. R is given to be 12.5 centimeter, means 0.125 meters, into eta. Eta is 0.95. Come on guys, think about it and let me know whether the answer is more than 2000 or is it less than 2000 or less than 1000. Come on, think about it. Yep, turbulent or laminar. Come on, you can see it very clearly what is happening. This 0.95 will go with this 1.9 and it will become 2, and this 0.125 will go with this 1250. It will become, check this out, 10,000 I believe. Oh, this is obviously going to be more than 2000, obviously going to be more than 2000, so hence this is going to be turbulent. That's it, you don't even have to find the value. Yes, correct. I hope this is clear. Very simple. These kind of questions come in the examination. Please remember, you can solve this very easily. So they will just trick you by giving the flow rate. A lot of people will substitute 1.9 as velocity. So please keep that in mind. It is not velocity, it is volume flow rate. So these are the stars of our last session. Ranjit is the star, very good. Dinesh is the star. Pramesh, 2 times he has posted. Acha, first question and second question. Then Saurav. Excellent guys, very good. Keep this up, and I'm hoping that you're going to post the answer for this question. Take a screenshot of this and this question. So this is the first question for today, for which you have to post the answer. 17s, I mean, the thing is, this Reynolds number was calculated for a circular pipe. For a square pipe or a hexagonal pipe, Reynolds number is slightly different. Okay, I hope that's clear. This is your first question guys. I hope you have taken a screenshot. Next question is this one. A square plate of 0.5 meter side moves parallel to a second plate. This is the second question. Post the answers in the comment section after the session is over, and the solutions will be coming up shortly on the Telegram group. So I'll be posting the solutions of the capacitor related questions shortly in the Telegram group, and today's questions will be coming up tomorrow or day after tomorrow, right? So please join the Telegram group, stay updated with all the important notifications. And for all the 12th and the dropper students, remember, I have told you the crash course starts every Monday. So do not miss this opportunity. Do not even hesitate once to join. Read everything properly before joining, but alright, because this crash course covers everything which is required for the JEE mains attempt. Remember that. So the crash course is discounted by 30%, so you get it for 7,000. That's very nominal, and you just have to put in the coupon code, which is SHCC. Alright, so go ahead, share the link if you think it is needed by somebody else as well. And guys, all the newcomers, I hope you're going to subscribe, because that's very important, or else you'll miss my next class. And I hope guys you have paid the fees for today's session by smashing that like button. I hope you have done that. What a lovely session this was. Bye bye guys. This was Shreyas here, your master teacher for physics at Vedantu. Take care. See you tomorrow at 7.